All right, so one way that we looked at this particular, the differences between the scales was the chart that we just used that showed each one was an increasing level of specificity when compared to the previous level. Well, another way to look at it is to summarize the measurement scales. You can read over this table here at this particular point in time, but I just want to emphasize something important. First, only the interval and the ratio scales are truly about quantity, something measurable quantity-wise. Ordinal is about relative frequency. So there could be numbers involved, like, what do you rate a particular restaurant? I rated a 5. But it's really just for ordering purposes, because a 5 restaurant's better than a 4 and a 3 and a 2 and so on. Is there an equal unit of measurement? Well, if it's quantitative, which interval and ratio are, yes, there is one. In the case of nominal and ordinal, there's not. And a good example is ordinal. Yes, you could have a number there, but there's no equal measurement between a restaurant rating of 1, 2, 3, 4, or 5. Is there a true zero? The only one that has a true zero that you could begin and only go up from is the ratio. Okay, that's a really important thing to remember. It helps differentiate between ratio and interval. How might the scale be used in research? Nominal, you just identify things as male or female, red or blue. Ordinal is, well, who came in first, who came in second, and so on. Interval is to convey the results of intelligence, personality tests, something like that, fitting it on a scale, something like how satisfied are you? 5 is agree, 4 is 5 is strongly agree, 4 is agree, 3 is somewhat agree, 2 is don't agree much, and 5 is completely disagree. Ratio, to count the number of correct answers on a test. In other words, we're getting an exact numerical count out of it. It's not representing anything, and there is a definite key difference between the numbers. Examples: nominal, telephone numbers, social security numbers. Yeah, they're numbers, but they're just used to classify. Okay. Ordinal are letter grades. A is greater than B, or is better than B, better than C, and so on. What elementary grade are you in? Because theoretically, a 5th grader is ahead of a 4th grader, and so on. In an interval, a checkbook balance is a good measurement scale for interval, and where someone stands relative to class average. So you could say, hey, I'm at the 50% mark or the 60% mark. And as far as ratio goes, if you talk about weight has a 0, has an absolute 0. You can't have negative numbers in ratio. See, if you have a checkbook balance, if you're like the federal government, then you can run negative numbers all the time. Intervals could have negative numbers. Ratios do not have negative numbers. Distance travels do not have a negative numbers. It is possible to go 0. 0 is an absolute distance. You didn't move. All right. So that's another summary of measurement scales. Now, what I'd like you to do is take a look at these 4 and do these 4, figuring what's the best, highest level of measurement scale, nominal, ordinal, interval, ratio, that you think applies. And then start her up again. So it's a stop-start deal. Okay, age is always ratio. Age is always a ratio kind of thing, because there's a 0 age, you weren't born yet, and then you start going up from there. And if you've been alive 10 years compared to 5 years, 10 divided by 5 is 2. That's a ratio you can have, and there's meaning to that ratio. 10. If you've lived 10 years, you have literally lived twice as long as someone who's lived 5 years. Okay. The ratings of movies released this month. Now, I think it's a little unclear. By ratings, I don't mean like GPG. I mean who comes in first, the best movie, who's the second best movie, the third best movie, and so on and so forth. Okay. Colors of athletic shirts sold by a local sporting goods store. That's nominal, because it's just a name that you're classifying it as. Is it red? Is it blue? Is it green? Temperatures of hot tubs in local clubs. In my mind, you could consider going back and forth between interval and ratio. But in this case, there is not an absolute. It's possible for temperature to be negative, first off. And we don't really have an absolute 0 we're starting from. All of the, or that can, you don't have to start from it, but that can be involved. So this is best known as interval. Temperatures is interval. Ages is always going to be ratio. Temperatures are going to be interval related. Another summary chart here, nominal, assigns different numbers to objects. For example, 1 male, 2 female. Ordinal, always about order. You finish in first, second, third, so on and so forth. Interval, here's the example, temperature and degrees Fahrenheit. It's very important that the interval be meaningful. For example, the difference between 78 and 79, 1 degree, is the same as the difference between 45 and 46. Now, ratio is this very important. It's underlined. Ratios have a meaning to them. They're not just like some abstract notion, and there is a true 0 point somewhere involved. For example, weight, you could be 0 pounds. Not many people are, but you could be. Finally, 10 pounds is twice as much as 5 pounds. Ratios are meaningful, okay? Now, a little bit more practice. We want you to take these 3 scales or 3 qualities, if you will, and then determine what is the highest level of measurement that can be used to measure each variable. And I see that, like an idiot, I forgot to make them come in when I click the button. So let's just talk about the answers. Blood types is nominal. What's the difference between green, red, and blue, and whether your blood type is O, A, B, or A, B, or AB? In other words, you don't order blood types, so it has to be nominal. Number of flowers in a bouquet, that's a ratio one, because there is the notion of 0 flowers in a bouquet, and the ratio makes sense because you have, say, you had 15 flowers as opposed to 5 flowers. There's a ratio there that makes sense. 15 divided by 5 is 3. And the ratings of fiction books, excellent, good, fair, poor, that's ordinal because you are ordering them. Okay? Now we have some concept questions to consider. I'm probably going to break off in the middle of these concept questions because of time. A survey asked people to identify their age, annual income, and marital status, single, divorced, married, etc., for each of these 3 variables. Identify the scale of measurement that probably is used and identify whether the variable is continuous or discrete. Remember, continuous means that there are infinite values in between and around it. Discrete means that there's nothing in between. Okay? Answer the questions, do a little stop and start here. So the first thing is, in terms of the scale, we said before, age is always ratio. So age can be a ratio scale. Annual income can be a ratio scale. If you're dealing with, like, for example, if you made 200,000, you made twice as much as someone with 100,000, and there is 0, because you can't, realistically speaking, you're not going to have negative income. If you allow for negative income, then it would be interval. But I'm going to go with the idea that you can only have 0 or greater income. Marital status, single, divorced, etc., that would best be known as nominal, because it's just a way of classifying. Now, as far as is the variable continuous or discrete, for continuous variables, there are an infinite number of possible values that fall between the 2 observed values. A continuous variable is divisible into an infinite number of fractional parts. That's what determines continuous. So, age is discrete. You are that exact amount of years old. Annual income. There are not an infinite number of variables in between. So that's also discrete. As far as marital status goes, it's not even quantitative in nature, so it's not going to be discrete or continuous. An English professor uses letter grades A, B, C, D, and F to evaluate a set of student essays. What kind of scale is being used to measure the qualities or the quality of the essays? You should do stop and start, of course, and it's ordinal because clearly you're ordering them in terms of how good they are. Concept question. A researcher studies the factors that determine the number of children that couples decide to have. The variable the number of children is it discrete or continuous? Well, it's going to be discrete because you can't have infinitely pieced up children, half a child, and so on and so forth. All right, so we'll carry on. After this, we're just going to talk a little bit about notation. So this is everything we needed to do in terms of the concepts with discrete, continuous, and the measurement scales.